So this lecture is about linear regression model. Particularly the focus is on the mathematics that works behind the simple as well as multiple linear regression models. So we start with this general form of a simple linear regression model. Y is equal to beta 1 plus beta 2x plus epsilon, where y is a dependent variable and x is independent variable, and beta 1 and beta 2 are two regression coefficients, and this epsilon is an error term which includes or which shows the impact of all the other variables other than this x. So, and epsilon is assumed to be normally distributed with mean 0 and variance sigma square. So this 0 is the mean of this error term epsilon, which is a random variable, and mathematically we write it as expected value of epsilon, which is the mean is 0 and second argument is the variance, so VAR of epsilon is sigma square. And we have also assumed that this is normally distributed, so we can relax this assumption of normality. So we can only say that okay, epsilon is an error term and it has mean 0 and it has variance sigma square, so normality is not necessary, but I'm going to assume normality as well, and later you may relax this assumption. So once we have this equation, then the next step is to write the true parameters. So true parameters of this regression model are number 1 beta 1 and next one is the beta 2. So beta 1 beta 2, two regression coefficients, these are included in the list of parameters, also called true parameters, and then the variance of error term, this sigma square, error term is epsilon, so sigma square. So we have three parameters, beta 1 and beta 2, the two regression coefficients, and third one is the variance of error term. So this completes our general form of a simple linear regression model. Now coming to the general form of a multiple linear regression model. In case of multiple linear regression model, we have more than one independent variables. So again we have the y as dependent variable, beta 1 plus beta 2 x2. Since we have more than one independent variable, so I started adding the subscript. So x2, beta 3 x3 and so on, beta k xk. So please note that here we started with this beta 1, and by the way adjacent to this beta 1 we have also x1 here, but x1 is assumed to be 1, so it means this first regressor is just a constant and the constant is equal to 1. So that's why we started this regressor from 2. So this 2 subscript, you can change this subscript 2 to x to from x2 to x1 as well, but just to be consistent with the notation of this beta 2, since the subscript 2 is used with beta, so beta 2, so then of course this should be just to make the notations consistent. So beta 2 x2 and beta 3 x3, so beta k xk, and it's up to you, you can even start with this beta 0 and then beta 1 x1, beta 2 x2 and so on. So anyway, so the idea is that we have an additional regressor here which is x1, but x1 is assumed to be 1, so that's why it is generally not written here. So this is the general form of a multiple linear regression model with k independent variables or k regressors, where first regressor is a vector is just a constant one, and this epsilon is as before. In case of simple linear regression model, it is assumed to be normally distributed with mean 0 and variance sigma square. And again this is the notation that expected value epsilon, which is the mean, and the variance is sigma square. And now in this case the true parameters for this multiple linear regression models are all the regression coefficients starting at beta 1 and going up to beta k, beta 1 to beta k, and then this last one is the variance of error term, which is sigma square. So this completes the discussion of how we can write the general form of a simple and multiple linear regression models. So now there is an alternative notation that can be used as well. So here we are going to show you an alternative notation of writing the same above two models, the simple linear regression model and multiple linear regression model. So we start with again simple linear regression model. Look at this mathematical equation. The mathematical equation is exactly the same. The only thing that we did is we added a subscript t to each of y and x And to be consistent with the multiple linear regression model, I started this x, I added subscript 2 with x as well. And epsilon t is an error term. And again this epsilon t is normally distributed with mean 0 and variance sigma square. And this 0 is expected value of epsilon t and variance of epsilon t. And then we need to define the range of t. So t ranges from 1 to big T, where big T is used to denote the total number of observations. So just to be clear that here we have x1 adjacent to beta 1. So but x1 is equal to 1, so that's why it is generally omitted. So in this model we have two regressors, x1 and x2. So that's why this 2 subscript is being shown here. So but x1 is, since x1 is 1, so this subscript 2 is optional. So in case of simple linear regression model, there is no need to add this subscript 2. But when you write the multiple linear regression model, of course this will be xt2 and next one will be xt3 and so on. So hopefully this point got cleared. So next we need to go to the general form of a multiple linear regression model. So in case of multiple linear regression model, again the mathematical equation is exactly the same. The only thing that we did is we added subscript t to each of y, x2, x3 and xk, and also of course with the epsilon, the error term. And epsilon t is normal with mean 0 variance sigma square as it is, and the range of t, it goes from 1 to big T. And also note that this t subscript t, it should occur before this subscript 2, which is subscript for the regressor. So x2 means the second regressor, x3 means the third regressor, so t is coming before that. So this is how we can write simple and multiple linear regression models. And as before, the true parameters in this simple case are beta 1, beta 2 and sigma square, the variance of error term. And in case of multiple linear regression model, the parameters are beta 1, beta 2 up to beta k, so k betas, and then this is the variance of error term sigma square, so we have k plus 1 parameters. So in this case we have 3 parameters, beta 1, beta 2 and sigma square. In this case we have k plus 1 parameters, beta 1 to beta k, k betas and 1 additional this sigma square. So we have k plus 1 parameters. So this is how we can write a simple linear regression model and multiple linear regression model without matrix notation. Now in the next slide we will cover the matrix notation of a regression model, linear regression model. So the idea of matrix notation is that we start with this multiple linear regression model and we do some basic mathematical steps to arrive to derive the expressions for this multiple linear regression model, this matrix form of a linear regression model. And now I'm going to add this multiple. So matrix form of a multiple linear regression model. So we start with this multiple linear regression model, the same equation that we wrote above, and the t ranges from 1 to t. Now in order to get the matrix notation, we need to do some basic algebra. So the first step is we need to replace this subscript t with 1 and then subscript t with 2 and then so on, subscript t with big T or capital T. So this is done here in the next few steps. So look at this first equation. So we have yt, this t is replaced with 1, y1, and then beta 1 as it is plus beta 2 as it is, and then xt2. So replace this small t in the subscript with 1, so it becomes x12, and then plus beta 3 xt3, it will become plus beta 3 x13 and so on, beta k as it is, xtk, it becomes x1k, and this epsilon 1. So this completes our this first model, the model of where we replaced t by small t in the subscript by 1. And by the way, this additional thing is not necessary to write, but just for clarity I have added that. Look at here, epsilon t is a random variable which follows normal distribution, mean 0 and variance sigma square. So when you replace this subscript t with 1, we get this epsilon 1, which is error at t equals 1. So this is a random variable which follows normal distribution, and mean is 0, variance sigma square. So mathematically expected epsilon 1 is 0 and variance epsilon 1 is sigma square. Now do what? Replace this in the subscript, replace this t in the subscript with 2. So it becomes y2, and similarly this becomes x22, x23, x2k, and epsilon 2 is normal with mean 0 and variance sigma square. And similarly we can write expression for y3, replacing t in the subscript with 3, and dot dot for so on 4, 5 and so on, replacing t by big T or capital T. So it becomes y big T, beta 1, beta 2, xt2 and beta 3 xt3 and plus beta k xtk plus epsilon t. Epsilon t is a random variable which follows normal distribution, mean 0, variance sigma square. So look at here, we have y1 this first equation, y2 second equation, y3 third equation, and yt is the tth equation. So if let's say this capital T is 10, so it means we will have in that case 10 equations. So here T is just a general notation. So we have capital T equations here. So this is actually called system of T equations, starting from y1 ending at this epsilon 1. So this is one equation, and here is second, third. So we have system of T equations, and by the way these are additional assumptions, so you can skip this notation as well, but it is good to write here. Okay, so we have system of T equations. In the next step, do what? Writing the above system of T equations in the matrix notation. So in matrix notation, the idea is that here stack all these values and put them in the form of a vector. y1, y2, y3, yt. All the values, they are occurring to the left of this equal sign. And then we will come to this expression on the right hand side. So here is what I did here. I put all the values on dependent variable y1, y2, y3 and so on dot dot up to yt in a vector. So this is actually a matrix, but a matrix that has only one column is also called a vector. So this is a vector, and then equal sign, and then look at these T equations. Now we need to, okay, so looking at here, so beta 1 plus beta 2 x12 beta 3 x13 and so on. So betas are being multiplied with all the x's. So in order to do that, and in the end we have plus epsilon 1 plus epsilon 2 plus epsilon 3 and plus epsilon t. So we did what? We added this epsilon 1, epsilon 2, epsilon 3, epsilon t as a separate vector, and betas were multiplied with x's. So we actually did what? So here adjacent to beta 1 we have 1, adjacent to this beta 1 we have again 1, adjacent to this beta 1 we have 1, adjacent to this beta 1 we have 1. And now look at this beta 2, beta 2, beta 2. So beta 2 is throughout same. Similarly beta 1 was same, beta 3 is same. So only thing that is changing 1 1 1 throughout here, and then x12, x22, x32, xt2 and then x13, 2, 3. So just doing some basic algebra. So I did what? I put all the x's here in this matrix notation. So this is 1, 1, 1 and so on up to 1. So this is for the first case, this first beta. So adjacent to beta 1 we have 1, 1, 1 so on. And now coming to beta 2 we have x12, x22, the second value of this x2 regressor, third value x23, so sorry 32, and then t2, the tth value. So here are the values for the second regressor. They have been put in this second column. Similarly look at the third column. Third column contains the values on third regressors. This second subscript 333 denotes the regressor, and this 1 mean first value, 2 mean second, 2, 3 mean second value of third regressor, 3, 3 mean third value of third regressor, and t3 means the tth value of third regressor, and so on. The kth regressor, x1k first value of kth regressor, x2k second value of kth regressor, and going up to xtk. And then we have put betas here, beta 1, beta 2 and so on up to beta k. Now let's verify whether we did it right or not. So this whole matrix, it is being multiplied with this column vector containing betas. So let's multiply first row by using usual multiplication rule of matrices. So first row will be multiplied by with this first column of betas. So 1 with beta 1, you get beta 1 plus x12 with beta 2, beta 2 x12, then x13 with beta 3, beta 3 x13 and so on, x1k with beta k x1k. So this is exactly this expression, beta 1, beta 2 x12, beta 3 x13 and so on, beta k x1k. So similarly, if you multiply this second row with first column with columns vector containing betas, you will get this expression. At the end we have this plus epsilon 1 plus epsilon 2 and going up to epsilon t. So they have been stacked here as a column vector, epsilon 1, epsilon 2 going up to epsilon t. So this is how we can transform this system of t equations into matrix notation. So once we have arrived it, once we have derived this, the next expression is, let us assume that this whole vector containing values on y. So let's assume that instead of writing this, let's introduce a shorter notation. So let's say that capital Y or big Y denotes this whole vector containing y values on dependent variable, and let's say this matrix is denoted by capital X or big X, and this vector containing betas, it is denoted by big beta, and this vector of errors is denoted by this epsilon or big epsilon. So once we have this, please note that since we are using now matrices, in matrices order matters. So look at the order or dimension of this matrix. So order means number of rows multiplied with number of columns. So if you look at this vector or this vector big Y, so it has this first element y1, the second element y2, third element, and it contains t elements. And now it has only one column, and it has this first row y1, second row y2, third row y3 and tth row. So order of y is t cross 1, t rows and 1 column. Now on the similar pattern, order of this big X is starting from here, this is row number 1, row number 2, and by the way, you can focus on this first subscript to count the number of rows. So 1 means first row, 2 means second row, third row, and capital T for the tth row. And now you can use this second subscript to count the number of columns. So this 2 means second column, 3 means third column, and k means k column. So order of X is t rows and k column. So it is t by k. And now coming to this big beta, it has this beta 1 first row, beta 2 second row, and going up to beta k the kth row. So k rows and only 1 column. So order of beta is k by 1. And last one is this vector of epsilon or errors, epsilon 1, 2, 3 up to epsilon t, it is of order t rows 1 column. So you need to keep the orders in mind because we will be using this order, the orders or dimensions of these matrices or vectors thoroughly in this course. So now instead of writing this whole thing, now in the next step we will simply use this y here, and this is big X, big beta plus big epsilon. So I'm calling this capital letters as big, but you can use simple big the capital Y in caps, X in caps. So here it is, y is equal to X beta plus epsilon. So again looking at this notation, so this is y equals X beta plus epsilon. So hopefully you got this expression.